Chapter 2, Section 1. We're starting off here, people, with a hot meeting. The reason I'm labeling Section 2.1 hot meeting is that we're using a term called perpendicular, and you may know what that means. In case you don't, here's the definition. It meets at right angles. And we know that right angles have a measure of 90 degrees. Yeah? So 90 degrees is kind of warm, hot. So there's my bad joke for the day. The symbol that we use for perpendicular is an upside down T. Sometimes people put a little box in the corner too, because that's another symbol that we put where two lines meet, and that would imply that those are perpendicular. Most intersections, like roads, yeah, that's what I'm referring to here, are at perpendicular. And there's a safety reason for that. When you are coming up to a busy road and you're on a cross road, you are looking this direction, and with your two eyes you get peripheral vision that is equally as good or bad from both sides. So if you weren't that way, it would be unsafe, and so most roads are built to be at perpendiculars. Little fact there. One place that you'll see this a lot was in algebra class, because you had to draw x-axis and y-axis, and those are perpendicular. Now you can't assume perpendicularity unless you have the symbol or they tell you the degrees at that intersection. So be careful of that. They might look perpendicular, but do not assume. So here goes a proof. We're given a diagram. Yeah, looks perpendicular. Isn't marked that way, but over here we can see that in the given they are in fact marked as perpendicular. So we could go ahead and put those little X's in the right spots. Let me change color pen because green doesn't work on green. AB and BC are perpendicular, and DC and BC are perpendicular. We are to conclude that angle B is congruent to angle C. So when we use the word conclude or prove, then that's something that we have to label, and I'm going to use columns. All right? Again, notice I'm starting off with my first two lines. Yes? So I just list those right there. And then that becomes the given. From the given, we can see that angle B and angle C are right, and that is the definition of perpendicular lines. Finally, if angle B and angle C are both right angles, then we know that angle B has to be congruent to angle C, because hopefully you can smell a rat. Yes, reminder, that's the right angle theorem, which says that all right angles are congruent. This next two problems are examples. So notice it says find, it doesn't say prove or conclude. So here goes. Find the measure of JKO, which is, you can see, is that angle there. All right. Well, we see that that angle is 4x, and we see that the other angle is x, and I know that these two lines, where they meet at K, meet at perpendicular. It's even marked in the diagram. So we know that x plus 4x must be 90. So 5x equals 90, which means x is equal to 14. Oh, I don't think I did that right. I think that's 18. All right. Again, we're trying to find measure of angle JKO, which is 4x. So 4 times 18 would be 72. All right. Last problem. This one does use our axes, our Cartesian system. We have angle E and we have angle T. Or sorry, not angle, but dot E. So this dot and this dot. And we need to find their coordinates. They seem to be missing. Well, because these are perpendicular lines, and in this case, the problem will tell you, this one did not specify, but it should say rect. Yes? R-E-C-T is a rectangle. And so based on that, we know that these are perpendicular. Now because of that, we can travel both in a horizontal direction here and know that our altitude won't change. We also can come up from here and we know that our left and right, call it east-west, is not going to change. So therefore E will be -4, 3. Using the same logic then for T. Again, T is down -2, and it's over 7, because again, we've just pulled those values off of that other set of coordinates. All right, well, 2-2, we will deal with complementary angles. Best of luck as you work on your homework problems.